In this video, we're going to look at TensorFlow datasets and how we can load different datasets, do preprocessing, and load the data efficiently. All right, so here are the datasets that are available through Keras datasets, which is what we've been primarily working with so far. And as you can see, it's relatively few, right? We've been working with Cypher10 and mnist. And if we now just look at the comparison of TensorFlow dataset, as we can see here, we have a bunch more datasets. So we have datasets for audio, images, I don't know really the difference between image classification, object detection, question answering, structured, summarization, text, translate, video. I mean, there are so many data sets on this one, so it makes sense for us to learn it. And it also becomes, so you can also load the data extremely efficiently. Now, I feel it's important to mention that what we're going to work with isn't the same as tf.data. So TensorFlow datasets makes it easy to load datasets, and it uses tf.data. But if you have, let's say, custom dataset that you want to load, you're going to want to use tf.data. So TensorFlow datasets is a high-level wrapper intended to make it very easy to load commonly used datasets. And in future videos, we're going to look at how to use tf.data to build an input pipeline for datasets that perhaps you've gathered on your own or scraped from the internet or something like that. With that said, there's going to be similarities since TF datasets is a wrapper for tf.data. So what we learn in this video is still going to be useful for when we load our own custom datasets. All right, enough talking. So what we're going to do now is actually take a look at the code. So what you have right here is just the standard imports we've been using. There are, I guess this one is new, and this one from import TensorFlow datasets as TFDS. That's new. So if you don't have those, you can Google how to download them. This one is just pip install TensorFlow datasets. They're also going to be in the description for the links for Anaconda and then also the command for pip. All right, so when you've downloaded that, what we're going to do is we're going to first just load the mnist datasets. So we've been working a lot with mnist, and we're all getting tired of mnist, I think. But this is really just for a simple use case of how it actually works to load it. So what we're going to do is we're going to do ds train, ds test. So we're going to get from this TensorFlow datasets, we're going to get a dataset for training, a dataset for test. And then we're also going to get some DS info about the dataset. So how we do this is tfds.load. And then here we're going to do mnist. So then we do split. And this right here, this string is just what you find on that the TensorFlow dataset catalog. And then you just write the dataset name as the string. And then we're going to do split, and we're going to do train and test. So this is to this we're doing ds train as the first output in this tuple right here. So that's why we're doing split train first and then test. Some data sets also have a validation, so then you would also add a validation string here. mnist doesn't have that, but so you would have to check for the specific data set, sort of what you have, what the splits are for that data set. Then we're going to do shuffle files equals true. So what TensorFlow datasets usually do is store things in something called TF records. And usually they store it in multiple files. So let's say they have 1,000 example per file. And the reason is that that way it can be streamed through. So if you're working with a server or something like that, it can be streamed over the internet, and then it can be loaded simultaneously while it's training. So that's quite useful if you're training on something like Google TPUs or something like that. And so what we want to do is we want to shuffle those files so that it doesn't see the exact same sequence of files, even though the batches inside of that sort of 1,000 examples are going to be shuffled and randomized. We still want to shuffle the files so that the ordering is not the same. All right, and then we're going to do as supervised equals true. And this means that it will return a tuple of a tuple of image comma label. Otherwise, it's going to return a dictionary. And then we're going to do with info equals true. So that's why we get this ds info. If we remove this one, set it to false, we're just going to get ds train and ds test. So first thing, usually we just do print ds info so that we actually see what the data set looks like. In this case, I think we already know it, but so the image shape are 28.1, and then the d type is tf.uint8, and then we have label. It has no shape, it's just an integer, and it's tf.int64, and then we have number of classes 10. Total examples are 70,000, 10K, and 60K for our training. And then you can sort of see citation, etc. if you're using this for a paper or something like that. All right, so if you also have newer versions of TensorFlow, I think it's 2.3 and up, then you can also do something like figure equals tfds dot show examples, ds train, ds info. So we're going to set in sort of the test set and then information about the test set, and or training set rather, and then rows, and we can set columns, and you'll see what this is going to do. All right, yeah, so what you also need to do is you can't do this as supervised. It's expecting to get a dictionary for this, so let's just rerun it with as supervised equals false, and then as you'll see, it will look something like this, where you can see some examples of your data set. So here we have 4 rows and 4 columns as we specified, and then we can see what the beneath we can see the name and then the label. Okay, so moving on, what we need to do now is we're going to create a function. So we're going to define normalize image. We're going to take in an image and then a label. And what we're going to do here, we're just going to normalize images. So essentially, we're going to make sure the image is tf float 32, and then we're going to just divide by 255 to get it in that 0 to 1 range. So we're going to return tf.cast image and then tf.float 32, and then divide by 255, and then we're going to return the label. And so what we can do now is we can do ds train equals ds train.map, and then normalize image. All right, so we're essentially, what this is going to do, it's going to map every single example and run it through this function first. And then we can also specify num parallel calls, since to send in to this normalized image, there's no inherent sequence that needs to be done in, so this can be done in parallel. So then we specify how many parallel calls it's going to do. And so you could specify this yourself. So let's say 5 or 10, whatever. It's essentially going to be a hyperparameter of your model. One cool thing is that TensorFlow lets you do auto tune. So it's going to sort of find what TensorFlow thinks is best. And then how to get auto tune, you would do tf.data.experimental.autotune. And then we're going to do ds train equals ds train.cache. And this cache is essentially after the first time it's loaded the data, it's going to keep track of some of them in memory so that it's going to be faster for the next time. And then ds train equals ds train.shuffle. And we can essentially set the buffer, sort of the shuffle buffer size, and let's say 1,000. So this means that it's not going to see the entire range of the data set, but it's going to also, this number kind of depends on the size of the files that in this case TF Datasets has stored them in. But what you could do here also is you could do dsinfo.splits, and you could obtain the train, and then you could just do .num examples, and in this way we're gonna be sure that it's gonna shuffle them randomly. And then we're gonna do ds train equals ds train.batch, and then we can set some batch size, and let's set the batch size above here. So batch size, let's do 64. Oh, all right, get that back. And then also we're going to do ds train.prefetch, and then we're also going to set auto tune on that. And then also here on the prefetch, essentially it's gonna, while it's running on the GPU, it's gonna prefetch 64 examples so that they are ready to be run instantly after the GPU calls are done. And then all we gotta do here is we gotta do it for the test set as well. So we gotta do pretty much the same thing. So we're gonna do ds test is ds test.map, normalize image, and then non-parallel calls is auto tune, and then we're gonna do batch. So we're not gonna shuffle it for the test set, and then we're gonna do, lastly, we're gonna do prefetch, and then auto tune. All right, so this is for the actual data processing, and this is going to be similar to when we're loading the data ourselves using tf.data. So this is already a TensorFlow dataset, which has been loaded very conveniently by this thing. But after that point, so this is exactly what we're going to do when we have custom data sets and so on. And then let's see, what we need to do now is just create a simple model. So let's do keras.sequential, and let's do keras input, so 28, 1, and then let's just do 1 conv layer, 32 output channels, 3 in kernel size, and then relu, and let's do flatten, and then 1 dense layer, and that's it. So all we got to do now is model compile, and you've seen all of this before. So model compile optimizer equals keras.optimizers.atom. We can set the learning rate, and then loss equals keras.losses.sparse categorical cross entropy, and then metrics is just going to be accuracy, and then we're gonna do model.fit on the DS train. So normally you would have to send in x and y. So if you have x and y, you would do x and then y. Now, since we have everything in this DS train, we can just send that in, and that's gonna contain tuples of the x and y labels. And then we can do epochs, set it to 5 or something like that, verbose equals 2, and then model.evaluate on the test set. And if there are no errors, let's see, and this hopefully works. Yeah, one thing we had to do, we did as supervised equals false when we wanted to do this show examples, but we got to do as supervised equals true for this to work. So let's rerun it, and let's see what's wrong. So what we got to do here is we got to do from logit equals true, otherwise this is not gonna train. So I think that's what we were missing. All right, so we get 98% on the test set, and so that's an example of mnist with images. I was thinking that we could also look at something a little bit more, I guess, something different in text classification. So this is going to be, I guess, a little bit more advanced because it's also going to be how to process the text and so on. We're going to do it very simple and try to focus on the data set, but we're going to look at imdb dataset reviews. So essentially that's reviews of movies, and so what we want to do is a sentiment analysis on these reviews of these movies and sort of interpret if the comment is a positive comment or a negative one. So let's just give an example. I mean, some comment might be this movie was terrible, and then we would give that a 0 since this is negative. And then if someone said this movie was really good, then we would set this to maybe 1, right? So that's sort of the data set we're working with. And what we're going to do is similar to what we did before: ds train, ds test. We're going to do and then ds info. We're going to tfds.load, and we're going to specify imdb reviews. We're going to do split is train and then test, and then we're going to do shuffle files equals true, as supervised equals true, and then with info equals true. All right, so the same as what we just did. Now what we need to do also is what we can do first of all actually is we can do print ds info, and then we can do, I don't know, something like for text comma label in ds train. We can do print text, and then let's just quit after one single example. So just so we get we get an interpretation of how it looks like. And then we got to do split. All right, so we get some information here. We get test, train. So we have 25K examples for training, 25K for test. And then this unsupervised, I think, are just comments that we don't have a label for. And then, yeah. And then we get great fun. I went with 8 friends to sneak preview viewing of this film. Yeah, so you can sort of, it's quite a long comment. But anyways, and so that's how it looks like. What we need to do first of all is actually tokenize it so that we don't get an entire sentence, because we can't send an entire sentence to a model. We need to first tokenize it so that, let's say we have a string hello, or I don't know, I love this movie, and then we're gonna do so tokenization, and essentially the output is then going to be a list of sort of the specific independent words. So I love, and then this, etc. You get the point. And then the next point is we need to actually numericalize it so that we can't send in a string here. We need to convert each of these words to an index using some vocabulary. All right, so what we need to do is we need to do tokenizer, and we can use TensorFlow Datasets for that. We can do features.text.tokenizer. And one thing here is that, so TensorFlow has a bunch of different ways to process text, and it's a bit confusing, to be honest. You have TensorFlow Datasets that you can preprocess it. Keras has a tokenization, you can preprocess it. And then there's also a library called TensorFlow Text that there isn't really that much information on. So yeah, I'm not really sure which one of these three are best. So far, this TensorFlow dataset seems to work fine. But anyways, after we get this tokenizer, we're going to define build vocabulary. And we're going to do a vocabulary. It's going to be a set. And then we're going to do for text, and then we don't need the labels in ds train. We're going to do vocabulary.update tokenizer.tokenize of that text, and then we got to convert it to numpy, and then let's do lower so that it doesn't really matter if the characters are uppercase or lowercase. And one thing, if you're very observant, is that we're adding every word now in our vocabulary, and that is not ideal, right? Normally you would set some frequency. Let's say if it occurs 5 times in our data set, then we add it to our vocabulary, because then it's an important word or something like that. So this is not really for efficiency. This is not for accuracy. I just want to show you a very simple example of how you would do this. And I think you can try to make this better and yeah, do something like check how many times that specific word occurs and then add it if it occurs a certain amount of times or something like that. And then we're going to return that vocabulary. And so we're going to do vocabulary equals build vocabulary. And then one thing we're going to do now is we're going to do an encoder. So as I said, we need to numericalize all of the tokenized words. And that's going to be done with tfds.features.text.token.text.encoder. And then we're going to send in our vocabulary, first of all. And then we're going to specify out of vocabulary token. So if we get a word that's not in our vocabulary, in this case, we're not going to get any, right? Because we're adding every single word. But anyways, and then we're going to do lowercase equals true. And tokenizer, we're going to specify our tokenizer. All right, so now we can define my encoding. And we're going to get some text tensor, and we're going to get some label. And what we're going to do is we're going to return encoder.encode that text tensor.numpy. So we're going to convert it to numpy first, and then we're going to return the label. So essentially what this encoder is going to do is it's going to tokenize it and then turn it into an index based on this vocabulary right here. And so it's going to do all of the things we need essentially. And then we got to do another function. So we're going to encode map, and we're going to send in some text and label. And the thing is here that the data loading is also part of the TensorFlow graph. So this is a Python function, and we need to do a function to we need to specify the inputs and the outputs of this function so that it's part of the graph. So we're going to do encoded text, and then label is tf.py function. So essentially we're going to specify that we're going to send it through some Python function, and we're going to specify the function, so my encoding, and we also need to specify the input. So this is because it's part of the graph. So we got to do text and then label, and then we got t out is tf.in64, tf.in64. So because when it's numericalized, it's going to become an integer representing the word in our vocabulary. And both are going to be integers. And then we also got to do encoded text.set shape. So we got to specify the shape, and we're going to specify none. And why we're specifying none is because we essentially have a sequence, and that sequence can be arbitrary length. Although the label are just going to be a single integer of 0 and 1. All right, and then at the end, return encoded text, comma label. So this can feel a little bit, I don't know, clunky, like unnecessary, but and there might be better ways to do it as well. This is just how I managed to get it to work, and it seems to be that this is a standard way of doing it. All right, so then we're going to do auto-tune is tf.data.experimental.autotune. We're going to do dstrain is dstrain.map. We're going to send it through encode map. That's what we call it, right? Encode map. And then num parallel calls is auto-tune. And then we got to do let's do cache, so .cache. And then we're going to do dstrain equals dstrain.shuffle. And let's just write 10,000. And then what we're going to do now is dstrain.padded batch. And we got to do a padded batch because all of the sequences in our batch are going to be different in length. So we need to pad it so that pad it to the longest example. And what we do here then is we do padded batch 32, and then we got to specify padded shapes. So we got to do none, and then just a tuple. So on newer versions on TensorFlow, this part is not necessary, but essentially what we're doing here is we're specifying which of the shapes that are going to be padded. So when we specify none here, those are for the images, or rather the text sequences, and that's the one we want to pad. So that's why we write none on that one. And then TensorFlow is going to know that we want to pad that one. And then we're going to do dstrain.prefetch, and then again auto-tune. And similarly for our test set, we're just going to do dstest.map encode map. That's it. And then we're going to do padded batch on that one as well. So dstest.padded batch 32, and then again padded shapes are going to be none and just a tuple. All right, so that was it for the preprocessing of the text and the data set. What we got to do now is create our model. So we're just going to create a very simple model, and then we're going to do, first of all, we're going to do layers.masking, mask value equals 0. So essentially here we're telling TensorFlow that the values that are padded, they're going to be padded with index of 0. Those values are going to be ignored in its computation. So let's say we have one sequence that's 1000 in length and we have one that's 20. Then that 20 in length is going to be padded by 980 of zeros. And performing the computation for all of those are going to be quite unnecessary. So when we're doing this layer.masking, we're just letting TensorFlow know that just ignore those values of 0, don't perform any computation. So then we're going to do layers.embedding. We're going to do input dimension is going to be the length of the vocabulary, and then plus 2 because we added one when we did this padded batch with index of 0 to our vocabulary, and then we also have one out of We also have one index for out of vocabulary words. So we're just going to add 2 on that. And then let's specify some output dimension. We're just going to specify 32, which is very small for an embedding size. Normally you would have 300 or something like that. But again, this is just for illustration. And then what you would also do is you would do some LSTM or some sequence model on this. In this case, all we're going to do is we're going to do global average pooling 1D. So let's just say we had 1,000 words in our sequence. And then what we did is we mapped this, each index, each word, we mapped that to an output dimension of 32. So essentially we had, batch size and then times 1,000 in that case. And then what we did after this embedding, we're going to get batch size times 1,000 times 32. So each word has been mapped to an output dimension of 32. Then after this average pooling, we're just going to get batch size times 32, essentially taking the average of all of the sequences for all of the examples. So then we're going to do layers.dense 64 activation equals relu. And then at the end, we're just going to add one dense layer. So let's just say it's going to output a single float value. And then if it's less than 0, then it's negative. So less than 0, negative, greater than 0, positive, or maybe greater or equal. So what we're gonna do here is we're gonna use binary cross entropy, and that's gonna use the sigmoid activation function. So yeah, I guess this part is a bit more advanced. So if you're not really following that, that's okay. But yeah, so what we're gonna do now is we're gonna do model compile. I guess also one thing you could do is you could do as we've done previously, where it would output 2 nodes, and then you could use sparse categorical cross entropy as we've normally done. It's just that when we have 2 classes, we can instead use another loss function, and that loss function is keras.losses.binary cross entropy, and then from logit equals true. And then we can specify the optimizer, keras.optimizers.atom 3e minus 4, and then we can specify the clipping value so that we don't get exploding gradient problems. And then metrics, we're gonna do accuracy. All right, and then in the end, we're just gonna do model.fit ds train. Let's do it for 10 epochs, and then we're gonna evaluate it on the test set. So again, this is not in any way for accuracy or something. It's just for demonstration of how we would take this data set from TensorFlow dataset, build a vocabulary, preprocess the text, load it efficiently, and then create a simple model just to show that it works. So let's run it and see what we get. All right, so first of all, can we just talk about how that ran without any errors on the first try? I mean, I wrote like all of this code and it ran on the first try. That gotta be the first time that has actually happened. So on the test set, we get 89% at the end, and let's see if we can scroll up. This is why I set the verbose equals 2, by the way. And then we get 96% on the training about. So well, we can, I mean, there's some room for regularization, and there's also some room we can try and train this for a little bit longer. Of course, we can make the model bigger and so on. But for this case, that's fine. So, all right, so hopefully this video was useful. I know this last part might have been a little bit advanced, but I also wanted to show you how you would do it for text. And I also want to mention that there are a bunch of different ways to do this. This is one way, and if you have an alternate way that you think is better, do something like this to process the text, then please leave a comment. But anyways, thank you so much for watching the video, and I hope to see you in the next one.